Concrete equations. How many green dots are hidden by the blue mask? Each of the blue masking units hides, contains, or masks the same number of green counting units. Each of these two pictures contains the same number of green counting units when the counting units, hidden by each blue masking unit, are included in each count. Determine the number of counting units that are hidden by each masking unit by using movable concrete masking and counting units, or by using their symbolic representations. The blue mask is represented by the letter B. The green counting unit is represented by the letter G. Remove one masking unit from each picture. Subtract one B from each picture. Remove 3 counting units from each picture. Subtract 3G from each picture. The blue mask hides 6 green dots. Each original picture actually contains 15 green dots. Count the dots in each picture to see. This represents an equality of counting units between two separate groups, including the counting units hidden by any masking unit. Now solve this visually concrete equation by using symbolic representations for the concrete masking and counting units. If an equation is represented in only the notational form and with no prior concrete representation, then it would not be obvious whether the equation represented blue dots hidden by a green mask or green dots hidden by a blue mask. Which is the masking unit and which is the counting unit? The steps taken to solve the equation depends on knowing the identity of the masking unit. Here we know the identity. It's represented by the letter B, the blue mask. What is a possible first step to solve this symbolic representation of the concrete equation of masking and counting units? Simplify each side of the equation and combine similar terms when possible. Remove one masking unit from each picture. Subtract one B from each picture. Simplify each side of the equation by combining similar terms. Remove 3 counting units from each picture. Subtract 3G from each picture. Simplify each side of the equation by combining similar terms. The blue masking unit contains, hides, or is equal to 6 green counting units. Now solve this previously visually concrete equation by using symbolic representations for the once concrete masking and counting units. Typically, when an equation is expressed notationally, only the terms indicating the masking unit are identified with a unique letter. The letter that would normally identify the counting unit in the terms of the equation is typically omitted, since the counting unit is always only equal to itself and does not hide or cloak any other unit. So the terms in an equation with the only observable denominant unit count the masking unit, whose corresponding value in counting units may vary from one equation to another. For this reason, the masking unit is called the variable unit, while the counting unit, as represented in the remaining unlabeled terms of the equation, is called the constant unit. For this equation, the masking unit is identified by the letter B. What is a possible first step to solve this symbolic representation of the concrete equation of masking and counting units? Simplify each side of the equation and combine similar terms when possible. Remove one masking unit from each picture. Subtract 1b from each picture. Simplify each side of the equation by combining similar terms. Remove 3 counting units from each picture. Subtract 3 from each picture. Simplify each side of the equation by combining similar terms. The blue masking unit, the variable unit, contains, hides, or is equal to 6 counting units, the constant unit.